Hello class, this is a video tutorial with more examples on rearranging the formula. In this set of videos, we are still making x the subject, so just be mindful in questions where it might be a completely different letter. In this set of 8 examples, we're going to look at these examples that have an x square instead. Okay, so here we go. So with this, initially, it's really the exact same thing as we've done before. So for this, we subtract 3, leaving us with x squared equals a minus 3. And now the thing that we need to do for this one is take the square root of a minus 3. This leaves us with x. The only thing when we take square roots of equations like this, we must always take the plus and the minus of that square root. And so that is how we tackle problems such as this. So let's keep going with this one. Notice how with this we have this negative again, and we'll see how this works out. So first we subtract b on both sides, leaving us with negative x squared equals 4 minus b. I'm going to divide by that negative 1, which leaves us with x squared equals b minus 4. And now we take the square root of this one. So this becomes x equals b minus 4 all square root. Now, there's a common problem that I've seen when teaching this. When you take square roots with pluses or minuses like this, the square root does not split into square root b minus square root 4. That's not how this works. If you have an expression that has b plus 4 or b plus something, you treat it as one group. It's in the next set of examples, these two, you'll see where what the misconception actually applies. So actually for this one, let's change this now just to really show. This becomes, let's say that this is 4, okay? So with this one, this will actually become, well, first we divide by c, like so. This becomes x squared equals 4 over c. Now when we take the square root, this becomes plus minus big square root 4 over c, like this. It's where you have division or multiplication where the square root splits, meaning this is actually going to now be square root 4 over square root c, and that plus minus is always better to give it to the numerator. Now, the interesting with this one, and the reason why I chose to change this to become a 4, is that square root 4 actually becomes 2. So the final form of this one is actually x equals plus minus 2 over square root c. So this idea where the square root splits into square root b and square root 4, what we're actually thinking is it splits only when there is a division or a multiplication, like in this next example here. Ready? So for this one, when we multiply by 16, we get x squared equals 16 times d, but I'm simply going to write it as 16d. Now when we take the square root, it becomes plus minus square root 16 times d. Okay, it's when you have, like I've shown you in this previous example, when you have a division, the square root splits into the numerator and denominator. Similarly here, this square root will split into square root 4, square root 16 times square root d. And this simplifies into plus minus 4 square root d. And that is the final equation of this. So be mindful, square roots only split when there's a division or multiplication. And we'll see that in these following examples here. Okay, let's keep going. So for this, notice how we have this 4x squared. So we actually have to do this plus 5 first. So we get 4x squared equals e plus 5. We divide by that 4. So this becomes x squared equals e plus 5 all over 4. And now here's where the split's going to happen of the square root. We get x equals, I'm going to actually leave it this time for you to see. It'll be plus minus big square root e plus 5 over 4. And this is now going to split into the numerator and denominator. So this becomes plus minus e plus 5, a square root on that one. And the square root, so the big square root, I'm splitting it into the numerator and the denominator. So it's square root 4. But notice how I'm only giving the plus minus to the numerator. And I've chosen 4 very specifically since square root 4 simply becomes 2. So this ultimately becomes plus minus e plus 5 square root all over 2. Okay, and that there is our final form of this one. All right, so let's keep going. At any time, you can pause and give this a go. And you'll see that with all of these, that I'm making it that you can practice that this idea where the big square root actually splits into the numerator and denominator. Okay, so let's keep going here. So for this one, we need to minus f on both sides. This gives us negative 16x squared equals 4 minus f. Remember again, we're going to divide by that negative 16. So negative 16, watch what happens to this 4 and the f. I'm going to make the 16 positive, but the 4 and the f, their signs switch. And once again, here's that square root one more time. We get that x equals, and I'm immediately going to skip to this step here. But remember, you have a big square root like this. So this becomes, oh, actually, I will keep it big square root like this, f minus 4 on 16. Now, this idea that I'm splitting the big square root, I'm choosing to do it since I know that 16 will become a 4. If this 16 were instead, say, a 15, square root 15 is not a integer. Okay, so I would actually leave it like this if I know that the numbers in the split won't simplify. But since this is 16, I know this is going to become plus minus f minus 4. So I've split it to the numerator, and the square root 16 simply becomes 4. So you need to critically think when you should split the square root into the numerator and denominator, and when you don't really have to. Okay, so let's move on to the final 2 examples here. So for this, we're going to have, for this one, notice how we've got that 2, right? But this one, we have the g first. So in this instance, actually, we'd actually want to divide by g first, because expanding this makes it much more difficult. Yeah, it makes it more difficult if we were to actually expand this group squared. So this actually becomes x plus 4 squared 25 divide g. Now when we take the square root, this becomes x plus 4 equals, I'm going to take the big square root, 25 over g, plus minus in the front. But remember, we have this nice 25 in the numerator. So by splitting this, this becomes 25 and square root 25 over square root g. We still have this x plus 4. Square root 25 is actually a neat number. That becomes x plus 4 equals plus minus 5 on g. And now we subtract by 4. And I realize we have very little room left in this one, which is fine. You can just move this down. Now we subtract, oh, sorry, my apologies. We need a square root g here. And now when we subtract by that 4, we have x equals plus minus 5 over square root g minus 4. Now, at this point, we actually can bring this into one fraction. I'll leave that for you as an exercise, but we're happy at this point here. Okay, so let's finalize this problem here. Last one for the video. For this, remember, it's not good to expand this group because of the square. It becomes more complicated. So we're immediately going to divide by 16, which gives us h minus x squared equals 9 on 16. Now when we take the square root, h minus x, if you consider that 9 and 16 are both perfect squares, so when we take the square root of this, you can check your calculator, by the way, the square root, so big square root like this, will actually become 3 over 4. And for this, again, I'm going to give only the numerator that plus minus. And so now, when we, well, from this point, we subtract h, we are left with negative x equals negative h plus minus 3 on 4. But as we've seen in many examples prior to this, we can't leave it at negative x. So dividing by negative 1, we get x is equal to positive h plus minus 3 on 4. Now, the plus minus doesn't change because it has both. So when we divide by a negative, the plus becomes negative and the negative becomes positive, which still gives us plus minus. All right, so I hope that's giving you an insight into these quadratic rearranging the formula. Hope to see you in the next video where we take on these examples that have square roots. Hope to see you then, and best of luck.